Hello and welcome to another edition of Unite Planet. We're in the kitchen of enlightenment for the first time in ages.
It is.
And we're joined by a regular guest. It's been a while, but we welcome back Andrew Johnson.
Thanks for inviting me back. Good to be back in the kitchen of enlightenment, as you say.
Yes, it's been a while, hasn't it? It's been a while. With this episode, we're going to be touching on mainly the climate change. That's all in the news at the moment, and obviously COVID is still hanging around, doing its whole thing in a clown show. So, start out is what you make of all, what's going off in the world at the moment, with the whole COP26 coming up and this whole focus on climate change.
Yeah, I mean, it's something which seemingly, I think we must have touched on it in one of our earlier talks, that they seem to be, there's a deliberate effort to kind of like, merge together the COVID scam and the climate change scam. I know I've mentioned this before and other people have picked up on it as well. And I think we may have mentioned it in our last discussion, but I think it bears, some repetition in that, for example, it was over a year ago now, actually, that both Boris Johnson and Biden were saying, "Build back better,"
Yeah.
And I think at least one of them said building back better means building back greener. And even Ted Ross Adhanom, who's the head of the WHO, he used the same phrase. He's talking about, when we had all the lockdowns, the best thing was that we had clearer skies, and cleaner rivers.
Remember that,
And of course he didn't present any evidence that was the case, although, you can logically assume, obviously, if there's less people flying, then there's less pollution. Again, and then we've had this COP26, but I haven't even had the news on, I had nothing on, so I don't really know who was there. I just know it's been going on. But I think, again, as with the COVID scam, what struck me as being unusual with this cycle of it is that, I go shopping at the co-op a couple of times a week just to pick up a few bits and bobs, and they've got posters in the window saying Co-op 26.
Wow.
And I read that and thought, well, I'm not reading the rest. I just left it at that. And then when I went into the shop, the announcements about, please continue to wear a mask for the safety of blah blah blah. They were also talking about climate change in the in-store announcements as well. Wow. And I've never heard that before. I mean, whether I'm much more attuned to it with the recent run of things, but again, it's really in-your-face stuff, and one has to wonder if, because so many people are switching off the TV now, that they're now exploiting other ways of getting into people's brains and faces, which are in essence less easy to escape, because you can't really go up to the co-op store manager and say, please, can you turn off your store announcements? It's really, I just think it's wrong that this sort of information should be put in our faces, But of course, this is how you get people to go along with the narrative, both with the COVID narrative and now with the climate change narrative. But of course, as somebody said to me the other day, one of the underlying themes of this is this phrase of zero carbon. We want to get to zero carbon. And I was actually up in, or rather down in Birmingham on Monday night. I saw Bernardo there.
Oh yeah.
He came down to the talk. We had a quick chat, and I might have even been him who said it. Actually, I can't remember. Somebody in the audience said, zero carbon means zero life.
It's the gas of life.
Exactly, and I think that's a valid sort of association. That they want to get to a point where they can say, look, they almost want you to have life and death, decisions on people because they are supposedly damaging the planet in some way. That's where this is all heading. But of course we have this Greta Thunberg or Thunberg or however you pronounce the name, saying the same sort of thing. And I'm still trying to work out who this person is supposed to be. I mean, clearly she can't be much of an expert. I think, she's 17, 18 now?
Yeah.
She was 16 when she first came. I think she was 14 when she first came onto the scene, wasn't she?
Yeah.
And somebody was saying, I've seen a couple of amusing memes on Facebook with Greta Thunberg is stuck in Glasgow and he's got a fag in her mouth and a bag of chips, you know. And so that was about the funniest thing to come out of it, you know, that can of lager, I think, something like that.
Her own persona, it's like set up so you can humorise it, you know, it's the way it is. It's really...
You know, and then of course we've got Charlie Boy, bigging it all up as well at every opportunity. And of course some people are saying that, you know, the Queen is dead now. She, as somebody sent me an email, and I'd heard this over the last couple of weeks, that the Queen has died, you know, and...
Unless she's been ill, hasn't she, recently?
Well, apparently, I think there has been a couple of headlines that she had nurses seeing her, or she'd been into, maybe not to hospital as much, but... that would not surprise me that she has died. And people have said, oh, you know, and Philip had died weeks or months before it was announced, you know. So what, you know, I know we've gone off the climate change a little bit, but it's still relevant because of Charles's role in things. And in fact, I was having a conversation with somebody in a small group locally that's started meeting, and one of that group, they were a solicitor. So I was saying, well, I'd heard years ago that there was a big problem with Charles in terms of the constitution of the country because he's meant to be defender of the faith. And he'd admitted adultery, you know, in one of the interviews that he did with about Camilla and Diana. This was going back sort of 10, 15 years. He had admitted adultery quite plainly, you know, in that interview. So I think people in the Church of England were saying, oh, you know, that's he can, because he's an adulterer, he can now no longer act as defender of the faith. Which I suppose is kind of ridiculous, really, considering all the other things that the royal family is involved with. You know, if we found out about them. But nevertheless, you know, the fact that this has all been kicking off when the Queen is in old age, is this going to be, certainly in the UK and well the Commonwealth actually, is this going to be another sort of I don't know what to call it, another weird lump of weirdness that gets put into the mix of things, and we're going to have this constitutional crisis in the UK and the Commonwealth because, of course, for those that don't know, the Queen is head of state. So in principle, the government can pass any law it wants and do anything, but the Queen can say yes or no to any law and not pass it. Of course, in practice, she just signs it, and I wouldn't be surprised if it's an aide that just signs it, with it being in old age and stuff. So if the Queen really is dead, how are laws going to be passed? How are they really actually legal? Or when is Charles going to step in and say, I'm king now, you know, or is he going to step in? Or are we going to see William, you know, as Prince Charles steps in for a day, abdicates, and then William becomes king, you know. So again, that's just sort of off the top of my head, thinking of Charles's role in promoting climate change, which he has been doing as a thing. Of course, as we know, going back to the actual thing itself, the climate change is a bigger scam than COVID almost, or you know, perhaps a longer lasting scam, if I can put it that way. I mean, maybe it hasn't quite had the same effects on our lives as the COVID scam has, not the same kind of immediate effect.
But they're moving it towards that level, aren't they? You know, that's that I'm
they
sensing.
Yeah. You know, and again, if you start to break it all down, what their arguments and what they say, it doesn't really make a lot of sense. You know, you don't even have to get particularly scientific. You know, like this whole argument behind electric cars, for example.
Yeah.
You know, and how they so how do they work? Then they run on lithium batteries. So where does the lithium come from? You know, it comes from mines. So what do you have to do to mine it? You know, what do you have to do to actually put that into a car battery? Or you have to do this, that, and the rest of it. So what's the total amount of carbon units or credits or whatever it is that would be created to create one car battery, say? You know, but nobody talks about that really. I mean, you get a few dissenters talking about it. And then, of course, you've seen the ridiculous situation just focusing on the electric car, the climate change type thing, where I think in regions where these directives get put in place, they have to build a certain number of electric car charging stations. But if they haven't got the power grid infrastructure to actually connect to those stations, what do they do? And you can easily find pictures now of a diesel-powered electric car charging station. So, it's the same sort of clown world. This is, I think, the phrase that you mentioned a few minutes ago. And I've seen we're living in a clown world.
It seems to be said a lot, and it's matches.
It
does.
It's bonkers.
And anybody really that thinks that climate change is an issue in the way that it's portrayed is they have no clue of what the reality is really. And this whole idea of climate change, the actual phrase, a bit like carbon footprint or zero carbon, doesn't really make any sense. It's a bit like saying, well, let's have light level change. We want to stop light level change, right? So we want to stop it from getting dark at night and getting light again in the morning. I mean, and I'm saying that because it's always happened. It's happened for as long as history has gone on. So is climate change. The climate changes all the time. So,
and not just on Earth.
And not just on Earth, and we'll mention a bit more about that. But so people are called climate change deniers, and that doesn't make any sense. I don't deny, for example, that climate changes, and I think if you have a proper, realistic, thorough conversation using the English language in the way it's meant to be used, you wouldn't find there are any people who say that the climate doesn't change.
It's that blanket kind of phrase they do. It's like anti-vaxxers, isn't it?
Oh,
they like to blanket all together, so it's
a Holocaust denial.
It's to package up, just dismiss. There you go.
That's right. So really, they've done another sort of bait and switch with that terminology, as we know. I mean, again, people listen to this. I'm probably just teaching grandma to suck eggs or whatever the appropriate expression is. What they mean is you disagree with the idea that human beings are affecting the carbon dioxide level in the atmosphere, which is therefore driving a process making the weather hotter. Or, actually now, it can mean the weather might be cooler. So the whole idea of global warming, they had to get rid of that because, of course, we had some winters which were really cold. In the last sort of 10 years, we've had some very cold conditions, haven't we, in certain places. So we've actually had some very extremely cold weather. So somebody somewhere thought, well, actually, we can't really use this global warming anymore because it doesn't apply to this place where everyone's just frozen to death. And last year, this time, it was tropical. It's, we've got to change it to climate change. So none of that makes any sense either. And this is all basic stuff. A lot of, like with the COVID stuff, a lot of it's basic stuff, like with the vaccine. Well, the vaccine either protects you or it doesn't protect you. The fact that my lawnmower doesn't work doesn't stop your lawnmower from not working.
That's the logic they're putting over into it. And it's so easy to break down, isn't it? So
yes, it is. And there's no evidence for this. And it's the same with climate change. Or the fact that you're breathing out is increasing the global temperature. So, you need to stop doing this or that, or you need to stop using this material, that material, whatever. Because people and the government and the media, as I write in my book, the climate change book, anybody that we didn't sort of talk about that, but, just about everything important that I'm going to say in this today is in that book. Climate change and global warming exposed, hidden evidence, disguised plans. So, for example, this whole idea of pollution is mixed together with carbon dioxide emissions. And they're two different things. Yes, of course there's pollution. There's been pollution for as long as human beings have actually tried to change the environment around them to do something to their own advantage. There's been pollution since humans started creating fire. So the first thing that should be done across all media, everywhere, is to have programs going out 24/7 describing the difference between pollution and environmental destruction and its relevance to climate change. That should be properly explained to everyone and to all children in school. You know, I'm all for example, using resources carefully, trying to reduce pollution, but reducing pollution is a different thing from reducing carbon emissions.
Yeah.
You know, that yes, there's some relationship, but you should understand what that relationship is and act accordingly on that basis. And we should have a zero pollution agenda, not a zero carbon agenda.
Yeah.
That's the important thing.
Yeah.
And that's what everyone really means, I think, in their mind when they talk about zero carbon. But because of all the language that's been thrust upon them, it comes out wrong, because they've been reprogrammed and they've been given the wrong terminology, and they don't bother to actually check their own thinking and what the underlying problems are. So really, that, you know, everyone can agree. I think there's nobody that wants to deliberately create pollution, and those that do just do it out of thoughtlessness.
Yeah.
You know, I mean, and you can see that every day. You know, I always think about when I'm just driving around and you get to a roundabout or something, you look out the window and there's fag ends and cans and plastic bottles and bottle tops and tissue packets and all kinds of crap just mixed in with the bushes, you know. And if people just put the rubbish into a bag, you know, and actually it seems to be worse in this country than it is in some other countries. It tends to be worse in the UK. So this again tells you something about the mentality of some people, not the whole of the population, that they don't really think about pollution. So if they're not going to think about pollution, are they going to think about climate change? Well, apparently, I guess some of them do, you know. But you know, again, we must separate those two issues properly, and that should be at the forefront of all government policy, all teaching, and all media reports. Distinguish the two.
I think the terminology, it's you see the same with COVID and the climate change. Like if you are a climate change denier, you are automatically lumped in with, you don't care about the environment either.
Correct.
So you're seen as careless.
Correct.
You're seen as that. And it's same with, I think, the terminology with the vaccines. Because this vaccine that's for the COVID is not like any other vaccine we've ever had. You know, it's a completely different thing altogether. Yeah. But that's another thing that people aren't registering. They're seeing the vaccine, the COVID, as like every other vaccine. Their argument is, well, it stopped polio and all this. But it's not even related. It's a completely different thing. Yeah. So it's all getting thrown in. So this anti-vax move, well, what they're putting on us as being anti-vax, they're just putting it like, I mean, there is some evidence about vaccines that, you know, what we're being told in the mainstream is not how it really is. I think that needs investigating as well. But we're just being thrown in with, you know, both the climate change and with the vaccine terminology. It's the same thing. You see,
it's guilt by association.
Yes.
You know, this is the common tactic that's used, and people like us who've thought about it will more readily see this guilt by association sort of technique used. But those who just want to go along and don't want to think more deeply, you know, question, is the underlying assumption that I've made in this scenario about vaccines or COVID or climate change, is that underlying assumption that I'm making based on the very poor quality information that's come out of the papers, the radio, is that assumption correct? And the answer in most cases is, I'm sorry, no, it isn't. You know, and of course many of the discussions that we've done are to really try and help people understand that a lot of those fundamental assumptions are wrong. And if you want to take the time, you know, you can work out for yourself why they are wrong, and in some cases what the correct assumption is, you know, in whatever scenario it is. And that's our goal. That's why we make videos like this. It's to, we hope, you know, improve people's understanding and get them to start a dialogue with themselves almost about, is this whatever I believe correct? Do I have the correct information? Do I have the full picture of the facts? And of course, going back to the climate change issue, as you mentioned a few minutes ago, one of the things we can observe if we look in the right place is the changes on all the planets in the solar system over the last 50 years, say.
Yeah.
In fact, the whole period when we've had space probes going out to the planets, and not only that, of course, some watchers will say, oh no, space is fake, and NASA's faked all the probes and all of that, because it can't go out from orbit. But actually, again, if you study that, that's another assumption that you've made. You might have originally assumed that all the NASA pictures were, and then you've changed that to assume that they're all fake. Be careful with that sort of assumption. Yeah. Because what I say to people is, for certain of these pictures, maybe it's only a small percentage, but for certain of them, and I've got some of this in the climate change book, there's one example in there, you can verify these images from the space probes with your own eyes, if you take the time and the trouble to do so. For example, just to give you one example, partly related to climate change, I think it was in 2010, if I remember the date correctly, and I'll try and send you this image that's in the book though. There was an enormous storm on Saturn. It was huge, it was bigger than the Earth, I think it was, or on par with the size of the Earth. It was huge. And in fact, it was so big, this storm, that you could clearly see it in a decent telescope. And amateurs took pictures of this, and lo and behold, we have the Cassini probe showing the same thing in high-resolution imagery, all the way from beamed back from Saturn. Is that fake? Is that NASA faking things? I don't think so. And there are quite a number. For me, there are enough other examples like that, which show you that yes, I would say the space probes must be in orbit. They are photographing the stated bodies. That's a different situation with the landers, I think. I think that's a lot more questionable. Yeah. But the actual things going round on another planet, I don't think that's nearly as difficult from an engineering point of view as landing things on a planet successfully. That's really hard. But the orbiting bit, I think, is relatively straightforward, as we can should all be able to accept if we acknowledge, for example, the way that your GPS navigation works on your mobile phone, etc., etc., and your satellite TV works, doesn't it? So anyone that's got Sky, how does that work? So we can, in other words, we can see changes in the solar system have been observed both with NASA probes, ESA probes, so it's not just NASA, remember, and also backyard telescopes and other telescopes, run independently of NASA. There are certain ground-based instruments that can make measurements. For example, one of the examples that comes to mind I put in my presentation, I can't remember to put this one in the book, is if you look at the atmosphere of Venus, what you can do is you can look through a telescope at Venus. It's fairly near. I think it's only like something like 50 million miles from the Earth, something like that. And you can then do what's called a spectrogram or a spectrograph. So you can get like a prism in front of your telescope or behind, I can't remember which, probably behind actually. And then you break up the light which is coming from Venus, and you can then detect within that the elements which are causing that emission of light to a certain degree. And so you can make a measurement, say, in 1978 of that spectrum, and then you can make a measurement 20 years later of that same spectrum, and you can see that it's changed. And the only way that would have changed is because the balance and the composition of the atmosphere in Venus has changed. And in fact, I can't remember the percentage off the top of my head, but it's like 10% more oxygen or 20% more sulfur or something in 30 years. So, and that's a ground-based measurement, that you can do. So again, unless you've actually studied a bit of science in some depth, you may not appreciate the way that some of this data is collected. And some of it is collected in quite a sophisticated manner, and some of it is collected very easily. And the way that you actually study that data is sometimes it's quite simple, sometimes it's quite complicated. Like, for example, if you want to do a spectrogram, you need the right equipment, which might cost, I don't know, £5,000, £10,000. So typically you would only get that at university, So again, you have to now review basic data and look at basic measurements and try and separate those from where they might appear in a scientific paper which has an agenda, behind it.
Yeah.
And typically the sorts of measurements that I've talked about in just now, like Venus, the changes in the composition of the atmosphere, that will just come from a basic observation from some database about Venus. And then going back to that sort of data itself, you can look at the polar ice caps on Mars. They actually reduced in size by about 70%, something like that, between, I think, 1995 and 1997. Again, I forget the exact years. But massive changes in the polar ice caps on Mars. And those images are from the Hubble Space Telescope. And again, so well, they Photoshop all of those. And it's true. They do Photoshop some of the Hubble Space Telescope images. But again, with Mars, it's near enough to the Earth that you can get some pretty good ground-based telescope images. I've looked at Mars through my own telescope in the past, and you can see the disk. I couldn't see the polar ice caps because my telescope wasn't that good. But again, if you have a fairly expensive instrument, you could verify some of those measurements yourself with the right equipment. So that's another one. And then the other one that's easily observable that I've got in the book and the presentation that I've done about this is Jupiter. Now, Jupiter, for example, it's an enormous gas giant. It's about 400 million miles from the Earth, but it's much bigger than the Earth. I think it's like 11 Earth diameters. So the actual diameter is 11 times that of the Earth. The actual volume is, well, it'll be pi r cubed times that, so that's certainly be about 150 times the volume or something. I forget the exact figure, but you can work it out. I'm not going to work it out on the fly. But anyway, Jupiter, gas giant, back in whenever it was, I think at the time of Galileo, even or soon after then, they found that Jupiter had an enormous red spot on it, on the near the equator. It was actually at 19 degrees. That's a whole other story. And so the Jupiter's great red spot has been known about and observed for 300 years. And they've seen it changing in size, and this is all ground-based telescope observations. If you've got a good enough telescope, and it's clear tonight, you can go out and see it tonight. Go around to your mate's house who's got to kind of see the red spot on Jupiter. See it with your own eyes, if you want it. Now, I think it was in 2008. Again, I'm hazy on the dates, but they're in the book. Jupiter suddenly had 3 red spots. The other 2 were smaller, but they were there, and then they disappeared. So does that count as climate change on Jupiter, do you think? And the great red spot itself is bigger than the Earth. Bigger than the Earth.
Wow.
So these are enormous, huge changes in the atmospheres of these planets. And then Saturn as well. That had changes in the rotation speed. According to an article I read by Richard Hoagland, they measured the rotation speed of Saturn, which is round about 10 hours. And I think when it was measured in the 1990s with some precision, I think it was like 10 hours, 40 minutes or something. And then when they measured it again, like 10 or 20 years later, it was 10 hours, 45 minutes. So again, that is some indication that the way that the atmosphere is moving around the planet, which is how they measure the rotation speed, using whatever instrumentation. Because again, it's a gas giant, so the measurement is not quite as simple as it would be for the Earth or for Mars, which are more solid, And so that was a huge change. And there were changes in the ring system as well that have been observed by a couple of the probes. They had these spokes in the rings that they observed with the Voyager probe back in 1980 or thereabouts. And then when one of the other probes, the later probes, went past, they couldn't see these spokes. Then later they did more observation and they found them again. Is that climate change? Is that people driving cars around on the Earth that's causing these changes? Same with Uranus. That everyone laughs at the name of that planet, of course, for obvious reasons. But that, whatever you want to call it, that has changes in the clouds, number of clouds in the atmosphere which are observable from the Earth. Hubble's observed that as well. So you can see it's primarily a sort of turquoisey blue colour is Uranus. But you get these bright clouds in the atmosphere, and a number of those were counted, and they changed. That went up between I think about 2005 and 2009. Loads more clouds appeared. I forget the exact dates, but you can see all these pictures in the book. And with Neptune as well, there was a dark spot that appeared on Neptune, which then disappeared. You know, Pluto as well. I mean, Pluto's got a very minimal atmosphere, but it is there. You can, if you use the right instruments, not something you could see with your backyard telescope. In fact, you'd be lucky to see Pluto at all from a backyard telescope. But measurements of that were made, and the atmosphere had become slightly bigger when it should have got smaller, because when it got bigger as it was getting further away from the sun. If I understand the data correctly, this was measured about 20 years ago. I think this was measured something like that, maybe a bit longer even. But in other words, when they did this study, you'd think that, well, if it's going further away from the sun, it's going to get cooler. So it's going to, the atmosphere is going to get less active, or it's going to shrink slightly, or whatever, because the gas isn't as excited or isn't heated up as much. It was the opposite of that, So is that us driving around, But the point of saying all of this is, clearly there are things going on in the solar system. Now, it could be that all those planets have their own processes going on inside of them, right, that's caused all those changes. Or the other alternative could be that we've got something happening in the whole solar system which isn't properly studied and isn't properly understood, which is again causing all those sorts of changes. Like, for example, some type of electrical energy that's flowing between the planets and the sun, or between the planets and each other, as proposed by the Electric Universe people, Wallace Thornhill and David Talbot and Donald Scott and the various other people. And anybody that's not looked at the Electric Universe, do have a look. They've got some really good lectures and things, and they do, I think, an excellent job of reinterpreting some of the NASA data, some of the ground-based observation data that I've referred to, and other things, and actually explaining why, for example, our climate change, however you measure it and whatever measurements you want to make, might be heavily influenced by this electrical energy, which is flowing either between the sun and the earth, or the other planets and the earth, or indeed the other thing that few people will talk about is what's called and I mentioned this in the book and in the presentation, the local interstellar medium, LISM. Now, you might have seen these, for example, these pictures of galaxies either from ground-based telescopes, and again, there's plenty of good YouTube videos now made by amateurs, and they're able to get a good backyard telescope. And I mean, I've seen one guy, I think he's based in the middle of bloody London, and he's basically set himself a challenge. He'll buy £100 telescope, get a cheap mobile phone, and then he wants to take a picture of the Andromeda Galaxy using that combination of £100 telescope. And you want to see some of the results it comes out with. It's called Astro Biscuit, right? He's got nothing to do with NASA, the videos he does are the brilliant, they're funny, they're entertaining, as well as
We'll give him on here.
Yeah.
With this bonkers looking telescope from my bedroom window, I want to show you clouds on the sun. Yeah, they really are there. There are clouds on the sun. The sun would easily melt my camera if it weren't for this special filter that I've got, which lets through a very particular wavelength of light, and if I get it just right, it'll show me clouds on the sun. Here we are, looks amazing, doesn't it? These clouds are very mysterious. The scientific bods don't really know why they're 1,000,000 degrees cooler than what's around them. By upping the resolution, it might be possible to see not just clouds, but rain on the sun. So keep your eyes peeled, because apparently if the plasma gets cool enough, it will fall like rain. But I'm not sure I can see anything more than a few spots of rain. So there you go, clouds on the sun, it's a thing.
Yeah. And he's got some guy that does the music, and he's edited well, in imaginative production, and zany. But like I say, so in other words, I'm digressing slightly, but it's really worth looking at some of those videos. And why I'm mentioning that is if you look at these pictures of galaxies, you can see like these dust lanes, right? So you can see bright regions, darker regions, what looks like clouds within the galaxy, right? So these clouds are either dust or gas or plasma. I'm not an expert on all the individual bits and bobs of this, but we are also in a galaxy that we're part of the Milky Way, and you can see parts of that galaxy if you know where to look at the night sky, and you can look towards the galactic centre. One of my friends who did a master's in astronomy, he did his thesis on observing the galactic centre, and he made some sort of new measurement of it or something at the time. This was 30 years ago. But what that means is that as our solar system is actually floating through space, we're within a galaxy, and within that galaxy there can be regions where there's more dust or there's more plasma floating around, and over time, we float into a part of the galaxy, the whole solar system. This is we can't really see it. We don't really, and there's more gas there. There's more plasma there. There's a higher number of charged particles, and that just affects our local interstellar environment. So that those particles, that gas, that plasma, could impinge on the Earth's atmosphere, and lo and behold, cause climate change. So there's that aspect, and then of course there's the more basic aspect than that even, of course, that Piers Corbyn talks about, which is the sun's effect on the climate, which beyond the normal daily cycle, hardly any of the climatologists want to talk about, even though the sun has the biggest effect on our climate of all, out of anything, just about, apart from maybe a lot of volcanoes erupting, something like that. But and it's well known that the sun's activity follows an 11-year cycle. So there's that 11 number again. And this is well known, and of course Piers Corbyn would be a good person to talk about. You haven't interviewed him, have you?
No, I'm not connected with him yet.
No.
It might be worth.
I mean, if you get an opportunity, I mean, he doesn't talk about some of the things I'm going to talk about, but he knows his stuff because he is an astrophysicist. Yeah. So he knows a lot more about.
I mean, I knew more for the climate change before the COVID.
Yeah, absolutely. So, that's exactly right. Yeah. And I went to a climate change meeting at the Royal Society, a public consultation group. I went twice actually, once in 2010 and once in 2013. He was there both times, I think. I spoke to him in 2013. But of course, Piers Corbyn, I don't know whether he still runs it, but he was running this service where he would sell weather forecasts to businesses or farmers or food producers based on his analysis of things like sunspot activity and solar flare activity, because of course you can get a gigantic emission from the sun. It's called a coronal mass ejection, and it's like a huge sort of cloud of charged particles. And some people describe it like the sun's burping, and that's quite a good analogy. And sometimes these clouds, depending on where they get ejected off the sun, they will go out to the solar system, away from the Earth. It depends on where we are in relation to where this sort of outburst happens. Sometimes they'll come directly towards the Earth. And if they're powerful, you can knock out the satellites. You talk to a radio amateur, and they will tell you that if they're communicating on shortwave radio, if there's been a coronal mass ejection, that may stop them from communicating for a couple of days or a few hours, however long it lasts, until the charged particles dissipate from the atmosphere, and they can continue communicating. And this is what causes the aurora borealis and the aurora australis, which is the one in the southern hemisphere that we rarely see. So what about those effects on climate change? They're not really talked about very much, if at all. And then you get into things like what's called the Maunder minimum. And that's what I mentioned in the book. And that, for example, is to do with the count of the sunspots. Again, with a backyard telescope, you get a telescope from Argos, 50 quid. Set it up on a tripod. Don't look through it. you point it at the sun, you get a piece of card, and you shine the eyepiece onto a piece of card, and you orientate the telescope so it's pointing directly at the sun, so you don't get any shadow on the card. You just see the image from the projected from the telescope, and you can see the sunspots, and you can count them. So these are observations you can do yourself. You know, don't have to take anybody's word for it. And that's what was done years ago, from the sort of 17th century. That people would get telescopes, project the image onto a piece of card, and they'd count the sunspots. And records have been kept around the world since the 1700s of how many sunspots can you see with a telescope on the disk of the sun, you know, on a given day. Count them one day, count them the next day. Now the sun has a rotation, I think it rotates once every 28 days. So you can see a sunspot one day, and then the next day it might grow bigger, and then it'll shrink, and then it'll move around the disk. And I've watched this, I've done this myself. You know, you can see these if you watch them over a couple of days. Of course, you're lucky in the UK to get 2 consecutive sunny days, aren't you? But, you know, get the idea. And, so you count the sunspots and see, you know, how many there are. And it was found that when there were fewer sunspots, in general, there was a strong correlation with a period of cooler weather. And this is what happened in the so-called Maunder minimum, where I think it was a period of 70 years, and it was there was very few sunspots that were counted in throughout those 70 years, and much lower than either side of that. I think it started in 1645. And this coincided primarily with what's called the Little Ice Age. So there was a period of about, I think, 20, 30, 40 years of cold weather. Now, I was speaking to somebody, or I watched a YouTube video about a couple of weeks ago. Some guy was disputing that a little bit, saying, well, actually the cold weather started, I think, 50 years before this low sunspot count. But I haven't studied that. Maybe the sunspot counts didn't go back that far, or whatever it was, but or accurate ones did. So there is a correlation between the number of sunspots and the weather on the Earth. So it's quite a strong one, I think, in terms of temperature. And indeed, more recently, there may be an explanation for why this happens. Because I think it was about 20 years ago. I think, again, I've got links in the book to the actual paper. But somebody realised what was probably going on. In that, I'll just try and get this the right way around. When the sun is got a lot of sunspots, it means that it's less active. So what happens is, it's more active. But basically, what that results in is when you're looking at the Earth, you get fewer cosmic ray particles getting through to the Earth, and that in turn creates fewer clouds, right? Okay. So there's a tendency to have less clouds when the sun has a lot of sunspots. So that means that the Earth warms up when there's less cloud. So if you've got less cloud, the Earth gets warmer. So that's why when you have more sunspots, typically the Earth gets warmer, because there's less cosmic rays get through. They create condensation nuclei in the atmosphere for clouds to form because of the particle interaction with the gases in the atmosphere. And therefore the Earth warms up. And that was studied by, I forget the name of the scientist. Was it David? No, it wasn't David Travers. But that paper's linked in the book as well. And of course they tried to refute this because, again, it goes against this idea of anthropogenic climate change. So, you have to look at all the evidence. And in science, of course, you get, I'm not a scientist. My background's in software. I did physics at university, and I've always valued science as a tool, but I know it doesn't have all the answers, and that's why we make these videos, But my point was that I count myself as a little bit of a polymath. I try to learn as much as I can about a lot of different things, rather than becoming a real expert on one particular area. And modern science typically favours the latter. It favours people who focus in one maybe 2 specific areas and become specialists. And then for most people and the way they work and the way that they're financially rewarded, it serves them to focus on a specialist area, you know, rather than becoming multidisciplined. Now, it's not the same for everyone, because some academics do, you know, sort of do a degree in one area and then they move to another area and another area. There's a few of them like that. And in fact, it's quite a few of those sorts of guys that turn up in the electric universe community. If you listen to, you know, some of those guys and look at their qualifications and stuff like that. So what I was going to say is that, and I say this in the book, I think, that climatologists won't talk about the data about the planets that I've just spoken about, and astronomers won't talk about some of the other data, you know, about things like the Maunder minimum. Occasionally you'll get them talking about that, but typically, you know, the astronomers won't talk about climate, and the climatologists won't talk about astronomy, you know, very much. They just regard themselves as separate disciplines when they're not. You know, they've got the sun affects the climate. You know, I mean, how hard has it got to be? You know, so and that's going to be one of the primary drivers.
I mean, this is the thing. Like, you find that within not just climate change, but then with COVID, with anything within science, is that like what you mentioned, they'll when people go into like academia, it's always one thing or two things, so they don't make that link.
No,
and I think that, I mean, I feel it's done on purpose. It's by design.
I think
so.
Right.
So people don't make those links, so they can't come to those conclusions as much as, at least, you know.
You know, and I mean, you made me think there when you were saying that about this phrase that's cropped up in the last few years, centre of excellence. You know, I mean, it's been used in the NHS and stuff, where they get all the specialists to go into work into one area, you know, and that sounds great, and maybe in some ways it is, but I think equally it can increase the tendency for people to become blinkered and talk to other groups about other areas, you know, which are important and have an impact on, you know, the issues that they themselves are studying, you know, and I think it's like you say, it's the same in healthcare and it is in climatology. You know, like, for example, doctors don't really talk about taking vitamins that much. Oh, yes, they do, but they don't. It's not a primary thing they would talk about in terms of, say, for example, COVID is taking extra vitamins. You know, and the ivermectin, of course, is it's used in horses, isn't it?
Yeah.
So you know, that's where you get this crossover of information can be useful. You know, and it doesn't happen in science particularly often. And like you say, that could be well the way it's been set up to, you know, and people of course are rewarded for following a certain path. You know, so you know, you go and get a PhD, you get more money. You know, you probably get more money from a job having a PhD than having 2 completely separate degrees. You know, typically. You know, which might make you more knowledgeable. So you know, so there's all of that stuff. So the climatologists don't talk about the astronomical data from the other planets, which is relevant, and the astronomers don't really talk about, you know, some of the other climatology data very much. So this is what I'm encouraging people to do. Some of these observations you can make yourself. Some of them you can look at other people's ground-based observations. You don't have to rely on people like NASA particularly for all of this. Some of it comes from NASA, but not all of it. And then, of course, we get into the other things as well, such as what happened on 9/11.